But this explains the launch. There's no other way to explain. That's why I say this, okay? I mean, obviously, because, you know, space-time and light have to be at sea. But this explains this. And I can't figure out any other way to explain this longitudinal thing, man. There is no other way to explain it, okay? This explains this now, okay? How this last piece of the puzzle, how does it, you know, like I said, I'm guessing here. But I do know that this sounds better than length contraction, and the entire universe is contracting, okay? We know that this or this is a Planck second. You might as well say that this, you know, then it explains everything. This is why you can't see, you have the uncertainty principle, right? Because in between this tick to here, right, nothing's happening. How can you see anything happening if nothing's there's no physics happening during this time. There's no time, you know. That's what makes time, because you have to go 108, light has to go that fast, you know, a certain speed on this Planck length, right? So that dictates how long, you know, physics can proceed, right? It can proceed at a Planck time, you know what I mean? Why? Because it takes time. This is the Planck length is the time it takes from the information to go from one atom to the other. You know what I mean? But apparently, you have to go to one atom to the other and back. Here's my conclusion. Every Planck, when you're standing still, everyone in the universe, if everyone was standing still, we would experience the Planck second at the same time, at the same exact time. And during that time, we would just be floating the way we were. We'd keep our momentum. But no physics could take place. No acceleration, no change in anything could happen except our momentum, you know, going through space. No thinking, no electronics. During that time, that Planck second, the only thing that's happening is information carriers are traveling from one place to another and then back. Okay? No physics is actually taking place. Okay? And everyone experiences this at the same exact time. So everyone freezes during this Planck second, except for our momentum. We keep moving with that, you know. And then when we start moving, right, like these guys, we stretch out our Planck second. But everyone in that frame that's moving at the same rate as us, they experience the same, the Planck second for all their physics and all their atoms is at the same time. They experience it all at the same time. When they freeze during that Planck second, okay, you know, not their momentum, but all their physics and thinking and everything. The only thing that's happening during that time is information carriers are going from, you know, this Planck second thing, bouncing back and forth to produce physics. No physics is happening during this time. No, you can't create any photons during this time, this Planck second. No information carriers are created. The only time you can create an information carrier is after or before the Planck second. That's why no physics is taking place, because the only thing that's happening during a Planck second is information to do the physics. I'm right about this. That's for damn sure. It's going at these velocities, the black ones, relative to this black frame, and it's going the c relative to this clock. That's a fact, okay? But this length contraction and all this crap, here's a good example of what I'm talking about. When they do this doublespeak thing, how many of them, and you know, if you watch physics videos, they've all said it. Oh, you'll be on a planet, and the guy's going to another star, and it's just length contracted. And you know, when you're on Earth, you can just see it, and it's just, oh, we just measure it. Can I ask you a question? If it contracts from, you know, in front, right, and it's going this way, that means this is going to be contracted. It's going to be contracted this way. It's length, right? Not it's up and down, right? So I mean, so the back of them is going to be still a circle, okay? How would you see this length contraction from Earth, from that point of view? If it if it doesn't contract up and down, you know, and back and forth or whatever, it only contracts front to back. How would you see it from this vantage point? Am I only one that sees that sounds crazy? that you see length contraction on this and you measure it. They always say, oh yeah, we measure it that way and blah, 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 blah. How are you measuring? What are you talking about? You can't see it from that vantage point. That's insane. What else are they saying? They're basically saying this is length contraction, and we know if that was the red ship, right, and it's going this way, obviously the universe didn't length contract and for one person and not the other. The ship just moved over into this, just like this is moving into this is moving away. That's where it seems like it's slow here and fast here. It seems like it's fast here and slow here. That's because over here they're coming towards. Over here the ship's going towards. Over here, you know what I mean? It's just it's not real, okay? They take this, and we know it's a perception, okay? We know it's not length contraction of ship move. We know the lightning bolts hit at the same time. We know that, man. It's just a perception because he's moving, okay? Then they took this perception up to here, and they glued it onto this, okay? So you see what they're basing all their things on. They're literally telling you that this person is going to see what this person sees. This is ridiculous. You can replace this with a photon collector. Now at least this is going to come at C. This is going to come at C because we said that. So they're going to hit this at the same time. The simultaneity is that the green person will see this person and this person hit their photon gun at the same time. Okay, that's the simultaneity, and I keep it, as you can see. By the time the photons hit the black man's going to be gone. Okay, this green guy ain't going to see nothing. Okay, so that's irrelevant. The first thing I want to say, length contraction is fake, so we know they're lying. Okay, I'm not saying this is right what I'm saying, but it sure would explain the longitudinal clock, why it's so funny like that. How can that be? Like, how can, like 1 second be this long and the next second is that, flipping back and forth? Well, just, if it's the Planck second going back and forth, you need two-way communication, then yeah, that's why. Then it doesn't matter that it does that. If it needs two-way communication, right? Who cares? Because everything within that Planck second can't be perceived by anyone, right? The uncertainty principle, like this would explain out, why we have the uncertainty principle, because we can't see and no physics is happening there. So how could we do anything to look at it or do it? You know what I mean? Why can't we pinpoint where a particle is, or the momentum, one or the other? You're uncertain on one, and this is why right here, because we can't see that. That's our uncertainty principle. This Planck length of this bouncing back and forth. Okay, the blue man and the red man and the green man and space-time all explained with this, everything except for this black man. Okay, he's the only one that I can't conceptualize because we're going to a two-way communication thing. Okay, but I kept everything up to the black man. I think is true. I really do. I think it's true. But like I said, I don't know. I can't prove it. Whatever. But because I can't conceptualize that last part. But we did keep our space-time relatively, at C compared to the photons and the green man, and two of them perceived it as being at C, if I'm right. That last guy. This is why we have a Planck second. This is why we have a Planck length. You know what I mean? This is why we have the uncertainty principle. This is why this longitude clock works when you're going, moving. Because a Planck second is, during that whole time, it's just time that you can't see. It doesn't exist, really. It's just time for information carriers to go from one place to the other. I learned simultaneity using a Minkowski diagram. You'd be going, this this would be your spaceship, this would be your 45-degree angle, and then that's how you find your x-axis for the moving man. You make the angles equal, see, and these two angles equal, and that's, you draw a line, and that is your new x-axis. See how I drew the blue ones? So this would be your time for the moving man. You know what I mean? To see how his simultaneity lines are different than this x-axis. Yeah, if anyone has any ideas, how could you have two-way communication? This is easy to, when it was one-way communication, it was easy to explain, easy to visualize. Now, it's hard to visualize. I mean, I could see how two-way communication, you know what I mean, when you're moving, it would just cancel each other out, but you would have to have your clock exactly, you know what I mean? It seems like, I don't know, I don't know. But we're just thinking about it for a couple weeks. I think it's a pretty good theory. Whether it's stupid or not, it explains a lot of things, but I can't get past that two-way, you know. That's why we always say, you can't measure the two-way, you know, thing of light, speed of light. The photon goes at 186,000 miles a second relative to space-time. Okay, so that Planck second is just the second it takes from information carrier to get from one atom to the other, or one whatever to the other. That's the shortest distance, like, so that's the fastest physics can happen. Okay, so that dictates how long you know, a second is, or a Planck second. But that Planck second that's happening, you can't look into it, because how could you look into it when you're frozen? Nothing is happening during that Planck length. Nothing is happening. That's why you can't find the, you know, the electron or the this or the that. During that time, nothing is getting processed. It's just information being, during that Planck length, it's just time. It's just information being transferred during that time. Nothing else. No physics, no nothing. It's just, it's the time in between where you're actually doing physics, you know, like, or having biology, or having your electronics. So all I'm saying is, you need two-way communication for the Planck second, right? And during this two-way communication, things get flipped back over, just like for the blue guy. When the photon hits the black guy and comes back, it gets compressed back to its original form, and the half C and the 1.5 C come out to 1 C to him. In the same way with the red guy. All I'm saying is that there's some type of two-way communication. I don't know how it is, but if it's true, everything makes sense now. Okay, but I'm making the light at C, and these are the correct thingies. 1.5 C and half C relative to this thing. You don't change that. They're changing that, okay? And this length contraction's a joke, okay? This isn't like the rest of my physics videos. I still haven't figured this out, but I think my theory is a lot better than their stupid length contraction BS, and they got different clock. This clock is going faster and this is going slower. No, they're just taking that, distilling that off of that lightning bolt thing, you know, 2 lightning bolts on an Earth, and they're just saying this happens because they think that happens. And we saw that lightning bolt thing had nothing to do with clocks being faster or whatever. It had to do with the ship moving into the one lightning thing and away from the other lightning hit. Just like here, this is moving forward to it, and this is moving away from the green guy. But again, this green guy ain't going to see or hear anything. This guy's going to be so far gone before any photons even hit the black guy. So they're basing it on lies, on perception. They're basing it on the speed of light not going at c relative to space-time, but c relative to these 3 guys that are moving. Right there, and they're basing it on this guy seeing when this guy gets hit by the photons when they're moving that fast. They're basing it, and they're basing it on the universe. It contracts first. We're all living in different universes that have different lengths, and you go to a star and it contracts for you, but for the rest of us it don't. This is magic, okay? My idea sounds crazy? Really? compared to that, all that.